Achab?
Yeah, Achab, yeah, fine.
Okay, thank you. Welcome.
Okay, thanks for the intro. Can you guys hear me well? Yep, okay, perfect. So I'm going to talk about Aave on Starknet, but I'm from Nethermind, so I'll try to explain that. Basically, Nethermind has a strong relationship with Starkware. For instance, we are building Warp, which is the transpiler from Solidity to Cairo, or Voyager, which is the equivalent of Etherscan, but for Starknet. And we have like a strong relationship, and they choose us to help Aave port their code into Starknet, so rewriting like Aave into Cairo. And in this presentation, I'd like to explain to you the work we have currently done, the work that remains to be done, and also the challenges you can have by writing Cairo code. So first, I'd like to introduce you to Starknet. So in a few words. So Starknet, like the correct sentence, it's a layer 2 of Ethereum based on Stark Proving System. So what does it mean? It means that it's an off-chain network where you can prove that the transition of state are correct using mathematical proof. And like the concept, the cryptographic concept to do that is Stark. This is why it's called Starkware and Starknet. And when you think about the proof, like an example you can think about like in the everyday life is like the receipt you receive at the restaurant. And this receipt, it will show you that the integrity of the computation, saying, okay, you have ordered that dish, the whole amount you need to pay is this. So you can really think about a receipt for a proof. And the goal of using L2s is to move the logic, the computation of Ethereum, and only use Ethereum as a settlement layer. So you will only store those proofs on Ethereum and do the computation and prove that those computations are correct elsewhere. So yeah, in a sentence, you can look at Ethereum as a decentralized Excel when you would only store the proofs. So a small diagram. So for people who are not familiar with Starknet, so on the top you have Starknet, on the bottom you have Ethereum. What you code is Cairo code, so it's another language. So you write your smart contract into Cairo. This is the part there. Where's the laser? Sorry. Here. That one. Okay, great. So here is your smart contract. So once you write your smart contract, like the trace, so the transition of state will be sent to what we call the prover. And this is what creates the mathematical proof. And then you send that into L1, so into Ethereum, and you store those proofs in what we call the facts registry. And this is where you store the fact that the transitions are okay. So this is where it works in practice. So yeah, that's it for Starknet. Now let's talk a bit about Aave. So Aave is one of the most famous DeFi protocol. So it's a lending protocol where people will deposit some tokens. They will earn yields on those deposits, and they can borrow assets from depending on the amount they have deposited previously. And Aave provide both collateralized and uncollateralized loans. The latter ones are called flash loans. And the current project, Aave on Starknet, has been divided into two parts, so two phases. The first one is already done. We are finishing the audit, and the second one we're about to start it. So the first one is bridge Aave tokens from Ethereum to Starknet. I'll explain that in the upcoming slides. And the second one is the bigger one. It's write the full protocol into Cairo. And I explain also the challenges you can meet by when you want to address that kind of problem. So the first phase. So the first phase was creating a bridge between Ethereum and Starknet. So the project is already done. We have the code open source. You can have a look at it. So quickly, what I call a token are Aave tokens. Those are the tokens you receive when you deposit some assets into Aave protocol. So they really represent the liquidity you have deposited, and you have like a one-to-one relationship, which means if you deposit like 100 DAI, you will receive 100 ADAI. And as I said, like in the previous slide, you earn yield when you deposit tokens on Aave. And this yield, you can think about like an interest rate, is called the liquidity index. And the number of A tokens you have will grow in balance over time, which means if you deposit 100 DAI, you receive 100 ADAI. And like over time, the protocol earns money, and then you will receive, for instance, 110 ADAI, which you can convert to back to DAI. And the main challenge between when building this bridge between Ethereum and Starknet is about like this rate, because basically you want to have the same rates on the two parts, but you want to avoid active communications, which means sending messages back and forth, like to be sure that you have synchronized the rates. And the design that has been chosen is to not implement a token the same way on Ethereum and on Starknet, but on Starknet we represent them as what we call static A tokens, and those static A tokens, the main difference between A tokens is that they don't grow in balance. So when you deposit some DAI, you will receive a fixed amount of static A DAI, but they will grow in value, which means that the tokens can be regarded as shares, and like when the protocol receives the money, the shares you have will have a bigger value over time, and again you can withdraw them and earn back your DAI instead. So this is the main part. So you will have A token on Ethereum, static A token on Starknet. This design is to avoid active communication between the chains. And yeah, so it works as we expect, which means that if you hold static A tokens on Starknet, you can convert them back into Ethereum, and you will receive the corresponding amount of A token that have grown over meanwhile. So now another diagram. That one is a bit more complex. You shouldn't look at everything, but basically, okay, my bad. L1 is Ethereum, L2 is Starknet. What we have built is the main part are the bridge on L1 and the bridge on L2. And what you can do is you deposit some assets, so DAI or A tokens into L1. So the L1 counterpart of the bridge will hold the tokens, and then on L2, the L2 bridge will mint static A token that you will hold, and if you want to convert them back into L1, you can do the other way around. And also, I haven't mentioned that during the talk, but we handle properly reward collections, which means holding A tokens gives you access to a reward token from Aave. So we also handle that part if you want to look at it. So the code is open source. You can find it on GitHub. So please send me a message if you want to have a look at it. So that part was really the first step of Aave into Starknet, and the main goal is really to deploy the full protocol on the chain, on the network. So this is what I'm about to talk, and I've decided to address to talk about the different challenges you can meet by writing a DeFi protocol on Starknet, because not all the contracts from Ethereum are available on Starknet. The design of somewhere are sometimes a bit different. So I don't know if people are writing Cairo in the room, but writing Cairo is currently pretty challenging. The syntax is a bit different from Ethereum, from SideDT, sorry. Still, the behavior is pretty much the same, but when you really want to translate some Solidity code into Cairo, usually you're doing a lot of mistakes. But yeah, it's to be, most challenges are to be fixed by Cairo 1.0 that has been announced yesterday. So yeah, this deprecates a bit this slide. And also, at Nethermind, we're about to release our guidelines to write proper Cairo code. But again, it will be also deprecated by the upcoming version, Cairo 1.0, probably released like beginning of next year. But still, most of the challenge will remain, and I'm about to address those in the upcoming slides. Yep. So the first one, like the biggest like dependency of DeFi is like the Oracle. So on Ethereum and EVM compatible chains, you have Chainlink. Chainlink is not present yet on Starknet, but still you have like two companies who are building oracles like in a different ways than Chainlink does. Those companies are called Empiric Network and Stork, and they both have like the same approach. So they have like they have contracts with data providers, which are like exchanges. So we can think about Coinbase, Gemini, like other famous names. And they ask those providers to sign some data, and then they integrate this data on chain. And this approach is similar to PIF on Solana. Yep, that's it. So they really have the same approach. So those are both deployed on testnet. I think Empiric Network is on mainnet now. Stork, I'm not sure. And also, like the nice feature is that they provide on-chain computation. Because I'll address that a bit later, but you can do way more computation on Starknet than on Ethereum. And for instance, those companies, they're doing stuff that Chainlink isn't doing on L1. For instance, they're computing the median of all those data on chain. They're also providing like volatility feed, which is missing like from Ethereum right now. And like they have like other features on the roadmap. And like at the end of the talk, I'll talk about what possible features DeFi can implement, like thanks to those features from the Oracle. So Oracle is a big part. Proxy is a bit different. So for people who are like used to write like Solidity code, you know that the proxy pattern is basically you deploy. For the transparent proxy patterns, you deploy two contracts, so the implementation contract and the proxy. Both like can have like storage and code, but at the end you don't use the storage of the implementation contract because all the storage is at the proxy level. For Starknet, it's a bit different because you can like deploy only some code, some stateless code into to the network. This is called contract class. And you can also deploy a contract, which is like storage plus code. And like the proxy pattern they advise us to do is to deploy like the implementation contract as contract class. So it means only code. The proxy has like storage and code. And then like the proxy will delegate the calls to the implementation, which only holds some code and no storage. So you don't have like that duplication of storage that you have like on Solidity. Here, like you only want to, when you want to implement the implementation, you only implement the code, basically. That's it. Now, several stuff on this slide. So as I told you, on Starknet, like the famous sentence is, computation is cheap, storage is expensive. I've written currently because there are some ways to improve that. To avoid storing everything and like only store hashes. But still, computation is cheap, so you can have like better approximation of math function than on Ethereum EVM compatible chains. And also sometimes like the design is a bit different because you want to store some stuff and you are okay to recompute them at the runtime instead of storing like the pre-computed values. Sorry for that. This is like one of the big difference. Also, the fees are really different because honestly, like the CPU of Cairo is very different from what we are used to as Solidity developers. And for instance, one thing that is really efficient on Solidity, packing several data in one UIN, for instance. This is like less possible in Cairo because bitwise operations are really expensive. And here, like basically tricks that people use to like optimize for the gas. They are no longer possible into Cairo. You should think about like other ways to do that. And like those bitmaps that are used in several protocols, yeah, we'd rather avoid that because you'd rather just have like the different data stored in different storage variables, and overall is like less expensive to do that. So yeah, this is a big difference as well. Now regarding Aave, so since we are not like working with the Solidity code, we don't have to. I mean, basically, when Aave gets deployed on Polygon, for instance, or another EVM-compatible chains, they use the same code, deploy it. So, like, you have the same implementation and interfaces of the token. Now it's a bit different because we have like a new language, and we can like take advantage of that to like standardize a bit. I mean, follow the new standards to do DeFi. And for instance, we can like implement the EIP 4626, which is like a standard to represent token vaults to ease the life of the integrators, because now they like it's. I mean, we have like some experience regarding pools, vaults, DeFi, and like we know that we can like encapsulate like everything in that standard. And regarding Aave, so it's compatible somehow with like the Aave token. We just need to add like a few functions to that. So this is one of the things we can do to like get better, ease the life of the integrators. Also, a tricky topic is A token versus C token. So since we're not using the same code and like the design is a bit different, it's the time like to think a bit about this implementation. And we're currently like researching a bit of that. And if like the C token implementation, so C token is like similar to the static A token I've described earlier, is like more efficient than the A token one, we can like switch the implementation and use an implementation that follow C token instead. So those things are yeah, the kind of thing we can do to improve a bit the protocol. Now, so yeah, I've made 2 slides to discuss about what I call the future of DeFi. Maybe it's a bit too much, but I wanted to talk about like new features that are possible thanks to Starknet. So the first one I wanted to talk about is capital efficiency, because now think about what I've said for the oracles. We have like a better okay, no, volatility is later on. Yeah, regarding the capital efficiency, so Aave implements what they call the E mode, which is the high efficiency mode. This mode, it basically tells you that if your assets are closed enough, for instance, the stable coins. So if you deposit stable coins and you want to borrow other stable coins, you can have like a higher threshold ratio than you usually have with other tokens. So because you say that stable coins, so they're all closed, so they have like it's like a small cluster of assets, and you know that since they're pretty stable one compared to the other, you can like borrow more because the price won't move too much compared to if you deposit DAI and you want to borrow, I don't know, a governance token, for instance. So this is currently, I mean, these groups of assets are currently static. They are like set per governance. They're not meant to change. Maybe, I'm not saying like that will be easy. Like a dynamic version of that may be possible, which means like you would group some assets together to increase like a bit the capital efficiency. Like you can think about, for instance, governance tokens like of the major contract. They don't have like a huge reason to go crazily high or crazily down, and like use like the fact that you can provide more computation. You can think about a way to group those assets dynamically, and then like enable a better capital efficiency. And now the second one is like basically use the volatility feeds to enable like dynamic changes. For instance, again with Aave, so Aave both provides loans with variable rate and stable rate. And like for the stable rate, the rate really depends on market conditions. So if the market conditions doesn't allow anymore like having like such a low rate, like you have like a governance process, and then the new parameters will change. Like in the future, this can be done like dynamically, because if you see that the volatility goes beyond one threshold, you can say, okay, we know that the good formula, like for the rate depending on the volatility, is this, and then you can like increase the rates for stable, for loans with stable rates, like automatically. So no longer rely on governance process. And also the second one, again, use the volatility to introduce dynamic fees. So it's like already like done by some protocols, some AMMs like on Polygon, Avalanche, but now you can do it better, because you can really look at the volatility in real time and say, okay, the volatility is high, so maybe we should like increase the fees for the AMM. And doing that, it will, people will less trade, and then you know that you will reduce somehow the impermanent loss for the liquidity provider, because the volatility is too high to trade, so people will just wait, and people who deposited money to earn like yield on that, they will lose less. So really, like the fact that you introduce volatility, it's it can become a game changer, because it allows way more dynamic use cases, and really ideally things are more handled in a dynamic fashion, instead of like waiting for the approval of like all the members and wait for a few days and weeks to have the change really on chain. So that's it for the talk. Now I'm open to the questions.
Hi. Thank you for the presentation. I do have a couple of questions.
Yeah.
Firstly, you mentioned the update of Cairo 1.0. Does that change the implementation that you did already like significantly?
Yeah, it changed the implementation. It changed like several stuff. So basically the blog post has been released yesterday, but they already mentioned that in a conference like two months ago. The main part, it's basically really developer experience oriented. For instance, now you can have like 4 loops, and you no longer rely on recursive functions. You have like way more types. We have like traits. They basically have like introduced several features that are available on Rust, and really, so it was pretty hard to do even simple stuff on Cairo like prior to that. Now it will be like way more easier.
And does that like for you as a developer disincentivize you in any way, like knowing that those changes will be upcoming all the time, to say like, hey, okay, I'm not going to implement this because I still don't have like the correct tools to do so?
Yeah. For instance, but still, like some points aren't so clear. For instance, one of the key question like regarding Cairo is like their native type, the felt, which is like basically an integer between 0 and like some prime number, -1. And so when you are doing overflow, you are going back to like on the first value. So it's really different from like uint, for instance. And this part, some people only want to use uint. Some people want to use felt. And the tricky thing is to represent a uint, you need 2 felts. So it's really not, so you're not optimizing for the storage doing that. And that part it's not so clear yet how they will handle that. So I would say that it answers to several questions, but still like some key questions aren't tackled yet.
Some more questions? Okay.
Hi, just a question about design. So why only move a computational part onto Starknet? Why not move like the like user interaction part on Starknet as well? Why not like build some kind of like fat dApp, which basically doesn't need users to go into Ethereum and get sucked up into the whole gas problem.
No, you can do that. Maybe it wasn't clear. This is the goal. The goal is really to have like the whole protocol into Starknet. So people will like interact from like Aave frontend with like the Starknet network. I was just saying that the advantage like related to computation, basically it makes you change like the way you will like implement some features. But no, I mean you can have like you can have like a protocol that only lives on Starknet, for instance. You're not like moving just like the computation part and then going like on the chain on L1 again.
So just a second question. So are there any plans to just repeat the same thing that is happening on Ethereum and just like bridge all the computation that's happening on the other L2s to Starknet again, or is it just for Ethereum?
I'm not sure to have got it.
So just like you're moving all the computational interaction to Starknet, are you planning to keep like open access? For example, a user wants to stay in Arbitrum or stay in Optimism because they don't want to do the migration to Starknet, so they can still interact and stay inside the L2s, but still interact with Starknet at the end of the day.
It's not really possible because like it's not about like moving computation. It's really about like rewriting the protocol. So you need to rewrite like your app into Cairo, and like really the computation. Think about it as a feature of the network. So we're not like moving just the computation part and then like storing the results. Like what I said at the beginning is just like an example for to like feel what an integrity proof is. So this is what I mentioned. Why I mentioned like the addition you have to pay at the restaurant, but really like the computation can be like any interaction you have on the chain. So calling one function, calling another function, packing all those transactions, this is what you prove. You don't only prove like one addition or like an exponentiation, you really prove a pack of transactions, and like each transaction, it has like a initial state, final state, and this was really like the one-to-one way to explain what an integrity proof is. Overall, we are like proving state transitions. This is what we're proving.
Thank you.
Yeah, I have a question. Are there, because I think other blockchains were also kind of struggling doing their own languages, like let's say Near, they were Rust-based and they end up building a EVM, like an EVM in Rust. Do you guys have any plans to, let's say, do an EVM in Cairo so people that already know Solidity doesn't need to learn a new language, or that's off the table?
There is a way to port your code into Cairo. There is a tool called Warp developed by Nethermind. And for instance, they made like an experiment last week. They ported the full Uniswap v3 code into Cairo. So like the transpiler like shows amazing results. So it's like I would say a quick way to have like your protocol ported into Cairo. But still, it won't optimize for Cairo because, for instance, it won't optimize for the computation versus the storage. You won't have human-readable code. So it's just like, I would say, a quick way to be on Cairo and on Starknet. But really, if you want to think about the way to implement, like optimize, you need to like learn the language.
Thank you, Massil. Thank you. A round of applause. Great presentation. Thank you.
Yeah.